Hi, this is Professor David Farina. In today's lecture, we will be discussing the Sun, our star, in particular the solar interior. Let's get started. So, one of the great ways that we can understand the universe around us is through mathematical models. And the Sun is no different. The Sun is a very simple yet complicated object. It's simple in that the only things that are involved here are gravity and the pressure from inside. So what we find is that our Sun is actually a very stable balance, something called the hydrostatic equilibrium, in which the amount of inward gravitational force is balanced by the outward pressure formed by nuclear fusion, which we'll talk about in a later video. Now, one of the main ways that we understand what's going on inside of our Sun has to do with the Doppler effect and our ability to watch as gases are moving either towards or away from us, with the gases that are moving towards us representing a blue shift in our spectrum of the Sun, or when they're moving away from us representing a red shift. Now, when we look at the Sun from its surface, we can actually see areas where the Sun has blue shifting or gas moving towards us and red shifting where gas is moving down. This indicates to us that convection is actually occurring in those layers of the Sun. Now, the Sun's density and temperature, according to our mathematical models, indicate that as you get closer and closer to the core, of course, the pressures and therefore the densities must continue to get higher. So much so that inside of the Sun we have the necessary density and temperature capable of producing nuclear fusion, specifically nuclear fusion with hydrogen. So the very much hot outer side of the Sun is actually very cool compared to the inner parts. The core is where all of those nuclear fusion reactions are taking place, and the radiation from the interior actually takes many, many hundreds of thousands of years to reach the surface. It does this through a process called the long walk, where effectively the light is being transmitted and reabsorbed by all of the different atoms within the Sun, and when they finally get to the convective zone, the surface motion here starts to get it all the way up to the photosphere, and then once it reaches the photosphere, the light from the Sun is taking approximately 8 minutes to get to Earth. Now, as viewed from Earth, we can actually see the photosphere in our telescopes, and when we look at the Sun, particularly through a white light filter, we see the photosphere as this boiling mass, and this convective zone is actually got this texture which we call granulation. Each of these granules is an area where the amount of solar energy here is coming upward in the convection cell, or darker areas where it's going down. So you can see here it's coming up, and on the edges it's going down. And it's similar to a boiling of a pot of water throughout this cycle, and as this convection cell is moving, each of them, once again, the size of Texas or so, we can really get an understanding of scale. So thank you for watching our video today, the Sun, our star, and the solar interior in particular. If you like this video and would like to learn more, please subscribe to the channel. And if you'd like to get a notification each time I make a video, please click that little bell at the bottom so that you get a notification from that video. Thanks a lot, and have a great rest of your day.